Here's a runner going for a nice jog, when suddenly he gets attacked. This is where ZenRun would come to the rescue.
The user picks a destination and the app gives them a route.
And then they're presented with an AI-generated safety classification for the route.
If the user leaves the road too far, they will be prompted to input the password.
If the user enters a distress password, the authorities are automatically called to their location.
So you're going to see the runner's going to open the app, and then they'll be prompted to create their password. After that, they're going to choose their route, and they will get their AI-generated safety assessment. They're running on Virginia Tech campus, which is an extremely safe area. Thus, it's going to give them extremely safe. But even if areas are generally safe, there's always the risk that something could happen. And you're going to see as our runners going along their route, they get attacked. And once the runner starts to deviate off the route, after they get attacked here, you'll see that eventually they are prompted and a loud alarm starts blaring. They're prompted to put in their password, and when they put in the wrong password, it makes the alarm go away to signal to the attacker that everything's okay. But really, when they put the wrong password in, the authorities or our proxy for authorities, which is this phone, is contacted in under 20 seconds.
The front end of the app was implemented using React Native, and we use the Expo framework. For the routing API, we use Open Route Service.
If the user sees something they believe to be suspicious, they can click a button to report a suspicious location. When the user goes off route, they'll be prompted to enter a passcode. If they fail to enter the correct passcode, or if they do not enter a passcode at all, 911 will be automatically called using the Twilio API.
So our backend use Fast API library to implement user management, password, and suspicious location marking. None of this function will work without MongoDB to manage and save the data.
We also had AI-generated safety classifications for the routes. We used the Google Places API to determine how many streetlights and the brightness of certain routes, and also to determine proximity to nightclubs, proximity to police stations, hospitals, bars, and other things that could make a location either safer or less safe. And then the route was rated from extremely unsafe to extremely safe, and we used k-means clustering to achieve this. So right here, we're going to demonstrate the k-means model in action. We're first using Blacksburg, Virginia on the Virginia Tech campus, which has their own police department and is close proximity to Blacksburg police, as well as lots of well-lit areas, not a lot of nightclubs, so it's generally safe. And you can see the classification is safe, which we're happy with and felt is accurate based on the crime statistics in the area. And then right here, we used an emulator to give a different location, which is in downtown Atlanta, Georgia, in an area that's notoriously not safe. And as you can see, once we put the route in, it's going to give that classification of the route not being safe to run on. And we tested the model with numerous data points, with areas that were kind of okay, areas that were very safe, areas that weren't very safe, all around the board. And we thought that our testing proved that the model was helpful and that the model was giving us the classifications that we would want to give accurate information to our users.
The runner launches the app and creates their password, as shown. They are then prompted to choose their destination. When they choose a destination, the safety classification pops up. And as expected for Virginia Tech's campus, the route is extremely safe. As the runner is satisfied with their safety prediction, they will go on their route. The runner, as shown in the clip, though, becomes hungry and decides to veer off and go to the dining hall. As the runner has veered off course, that they are prompted to enter their password. The runner in this instance enters their correct password, and thus no 911 call should be triggered. As demonstrated by the lack of anything on the phone, no 911 call was initiated. In the following clip, you will see me select a route and observe the route safety classification.
You're gonna see him getting attacked by evil Junkai, and he's gonna be prompted to enter a password.
And he's never going to enter a password. And then when no password's entered, you'll see that our proxy for 911, which is a different phone, is instantly called. Once again, the runner's going to create their password and then choose the route they want to run along. This time they're going to veer off course and never enter a password, and 911 will still be called. For what we determined as too far off course, it's just a hard-coded value, but we really cut it down for the purposes of the video. The time between being prompted to put in your password and calling 911 is also hard-coded, and in reality, we would choose that based off research and development and people testing the app. But for the purposes of this video, we made it a very small distance and a very small amount of time so that we could show the call triggering correctly. So as you're going to see when they go off course and don't put a password in, then 911 or our proxy is contacted.
Hello, this is 911.
As you can see in this clip, the runner pulls up to a suspicious location and becomes alarmed at what he sees. Upon observing the situation, he chooses to report the suspicious location in the app.
If you have any suggestions or questions, we'll gladly listen to them.
Thank you so much.